Okay, looks like you found the second answer key video. Hopefully you've worked on these before you're looking at this. Directions are still to factor. So what do I decide first? How many terms I have. So let's take a look. I see this subtraction sign, but I also see this addition sign kind of sitting in the middle of everything, right? So to the right of this subtraction sign, there's a multiplication problem. So one term, yes? After the subtraction sign, I have 5 times this parenthesis, and then I hit addition, which means that's term number 2. And after the addition, well, that's term number 3, right? Okay, so after you decide how many terms, good, what's in common? This one, gratefully, is pretty obvious. We have x plus 1 in common with all of them. And you have to decide what power you're taking out. One of them has a power of a half, the other one 3 halves, the other one 5 halves. Which one do you take out? Good, the smallest. The smallest would be 1/2. Way to go, guys. Excellent. You're getting the hang of it. You always take out the smallest power. Okay. So I'm taking out x plus 1 to the power of a half. Let's see what remains. So I definitely have a 4 here. And these guys are going to completely drop out, aren't they? Okay. Second, after the minus sign, we have the 5. All right, so the base is x plus 1, and I'm dividing. So remember, the numerator power is 3/2. The denominator's power is 1/2. What do you do between them when you divide? You subtract, which 2/2, it's just a 1. So I have x plus 1 to the power of 1. Cool. Boop. And now I see the plus sign. And now I see x plus 1 divided by x plus 1, the same base, but the powers. The numerator is 5 halves. The denominator is 1/2. What do you do between the powers when you divide? You subtract, gives you 4/2. Oh, wonderful. That's a square. Okay, that wasn't too bad. As long as you find the correct power to factor out, the brackets aren't too bad. What remains in them is not too bad. So we definitely have 4. Would you agree it's minus 5x minus 5? Plus. Okay, I'm going to do this off to the side. We have x plus 1 times itself, right? So some of you still should write down every little step to make certain you distribute correctly. It took, what, maybe all of 2 seconds to do that? And that way I know I have it right. Okay, let's look at our next line. So we have x plus 1 to the power of a half, and in the brackets, combining like terms. So it looks like I am going to combine, well, x squared is just x squared, right? And then I have a minus 5x and a positive 2x. That would give me a minus 3x, agreed? And then I have 4 minus 5, which is negative 1, plus 1, oh, 0. All right. So what I have left in the brackets is x squared minus 3x. It's a second degree polynomial. Does it factor? It sure does. You can, and we've been doing it, you can take out what's in common, which would be an x, and you're left with x minus 3. And you're like, where'd the brackets go? Well, question. Once I factored them, do I really need them? Nope. And I'm going to write this with the x first, because we usually write the single term first, only because it looks nicer. And it doesn't matter the order in which I write the other 2 parentheses either, because all I'm doing is multiplying. Some of you may have written the x minus 3 before the x plus. It doesn't matter. It's the same answer. Good? Okay. Problem number 2 coming your way. So here's problem number 2. Did you get it? Did you understand it? Go to problem number 3. In the meantime, those of you who want to see the work, let's do this. What do we identify first? How many terms? How many did you get? Good, 2. I'm agreeing. I see a plus sign in the middle, multiplication problem to the left of it, multiplication problem to the right of it, definitely 2 terms. What did you decide was in common? Because we know that's our next step. You said the parentheses of 5a minus 1. I agree. And what power did you decide to divide out? To the negative 1/4, because, yeah, that's the smaller of the 2 powers. Loving it. So let me write down what we have factored out. And in brackets, let's find out what remains. So definitely the 2, correct? On the first term. Now, I'm dividing the same base. My numerator's exponent is 3/4. My denominator's exponent is negative 1/4. What operation do you do between the exponents when you divide? Subtract, which makes it an addition problem. Aha! I'm liking that. And you know what? A good 99% of the time, this is exactly what happens when we've done it correctly. Sometimes, when you've done it correctly, sometimes that power is still a fraction. Just saying, that's like a 1%er. So don't get freaked out if you're like, oh my gosh, it didn't turn out to be a whole number exponent. Well, c'est la vie, you're sophisticated. So 7a, definitely after the plus sign, and these drop out. Good, excellent. Ready for the next line? I'm assuming yes, because you're like, oh my gosh, I get this. I got it. So we have 10a minus 2 plus 7a. And when I simplify what's in brackets, I have 17a minus 2, don't I? Did you get that? Does it factor? You're right, it doesn't. There's your final answer for problem 2. Cool? Great. On to problem 3. Problem 3, here we are. Tell me what you did. Okay, identify the terms. How many? 2. Very good. Here are my 2 terms. What did you decide to factor out? X plus 2. Wonderful, because they have those parentheses in common. To the smaller power, which is negative 1/3. Very good, guys. I should give you the pen. You should come on this side and... Anyway. So, factoring out x plus 2 to the power of negative 1/3. So, tell me what remains. Good. Definitely have the 3x on the first term. These drop out. Plus. Definitely have the 4. And now I have these exponents. The numerator is 2/3. The denominator is negative 1/3. And what do you do when you divide the exact same bases? You subtract the exponents. Aha! Loving it. Man, this is working out nicely, isn't it? Are you getting the hang of this? I hope so. I do have another problem after this, but it's always good practice to just keep working on these, because sometimes when you have these oddball exponents, it kind of messes with your brain. So the more you work on them, the more you conquer them, and the easier they become. What's the word I'm looking for? It works the brain muscle. Some of you go to the gym and you exercise your body. Well, this exercises your brain. Cool? Okay. I know I've been writing as I've been joking with you, but that's okay, because I know you already have this answer before I even got to it. Agreed? Excellent. Can you factor what's in brackets? No, there's nothing in common, so we're good to go. All right, number 4, heading your way. Problem number 4, did you get it? Good. Okay, let me see if I agree with you. Let me see if my answer and your answer are the same. More than likely they are, because you're getting the hang of this. Okay, I am going to identify the number of terms. I see my plus sign. I see only multiplication to the left of it, only multiplication to the right of it. 2 terms. I noticed that the parenthesis x plus 2 is in common, so I'm going to divide out this parenthesis. And I decided to divide out to the 2/3 power because it's the smaller of the two powers. Did we agree? Yay! Okay, let me catch up to you. Hold on. Okay, so you took out the x plus 2 to the power of 2/3. Let's see what remains. First term, you definitely have the 5. These guys dropped out completely. And you have 3x minus 2. Now I've got the plus sign, and I have the 9. And I'm noticing x plus 2 is the same base, but the exponents are different. So the numerator's power is 5/3. The denominator is 2/3. What did you guys do between them? You subtracted. And lovely. We end up with x plus 2 to the power of 1. Great. This is good. Okay. Did you already take care of what's in parentheses? Probably did. Because you guys have the hang of this now. And I'm glad for that. All right. So 15x minus 10 plus 9x plus 18. I'm collecting like terms, so what do we have? 24x plus 8. Okay, did you get that? Good. The question is, are we done? Good, you're not. Because in the brackets, you have something you can actually factor out, right? And some of you are like, oh, I didn't see that. It was so focused. I know, you were so focused on taking care of this factor from the beginning that you were like, darn it, I forgot that we could actually factor out an 8. It's okay. If that's the only thing you missed, well done. But just always remember, when you simplify what's left over, you still have to see if you can factor anything out of it. And in this case, I could take an 8 out. Sometimes we have a second degree polynomial left, as you have seen. And sometimes those factor. Cool? Excellent. Okay, if you still need some more assistance with these, if you want more practice with these, I actually have a few more examples coming your way. So take a look at them, work on them, and yes, there's an answer key video to them. And I think that's it for now. Catch you on the flip side.